the average was range. Somebody got a perfect paper, including the extra credit. Congratulations. So 105 to 60. The average was, I think, around 83. Strangely disquieted. There were questions that I thought some people didn't understand, which meant somehow I didn't do a very good job. A few people, well, okay, so there's some nitty things about, number one. Most of you got a bunch of it right, which is fine. It's kind of, at the beginning I wrote like a set of Venn diagrams. I could see maybe you forgot the natural numbers are just 1, 2, 3, and so forth. Integers, like you add 0, minus 1, minus 2. And then you get the rationals, which includes the fractions, A over B. I can see where someone might mistake, well, wait a minute, like this -5 irrational. Well, -5 is, that's over here, it's an integer. It's -5 over 1, so it's still irrational inside. So that's all okay. That's kind of nitty stuff anyway. We did a whole thing on factoring and prime factors, and some people kind of took 84 and they factored it, but they didn't really go far enough. Like 4 times 21 or 2 times 48, and 21 and 4 and 48 aren't prime. If you're confused about that, it's kind of basic. And while it may not seem to show up very much, it's really helpful when you're trying to reduce something. You're trying to reduce a fraction. So, again, these are things, if you have an issue with them, I'm here all day from 11:30, I run and get my lunch, and I'm sitting in my office lonely. You can come and get help if you need help with some of these. I was kind of scratching my head on number 10. 10 is the triangle. And got me thinking a lot. I don't really want to go into the mistake a lot of people made. I want to talk about math. See, you probably wouldn't be in this class if you didn't, if you understood this well. You can kind of figure out math on your own if you spend a little time with it. And most people who are in this class have not had a real good experience with math, and so they're not inclined to. I understand that. I'm not expecting to turn anybody around here. But I do at least want to show you that there are, in the middle of an exam faced with, I have no idea, or I don't remember the formula or whatever. Math is, in a way, it's not like history, like I don't remember the date, you're stuck. The things you can figure out. So I want to talk about area for a second and show you just what I mean. So the way we usually start with area is we start with a square. and the square has sides 1 and 1. And we call that a square, and it has an area of 1 square unit, whatever that is. We'll just use centimeters for lack of anything else. So 1 times 1 centimeters squared, that's an area. It's the units of an area. Okay, well, where do we go from there? Well, we have something like a rectangle. And we'll make it simple. The rectangle is 2 by 3. So it's got 1, 1, 1, 1, 1. It's 2 by 3. And how many of these 1 square units are there? Well, you could just count them. 1, 2, 3, 4, 5, 6, or you can see the obvious. It's just 2 times 3 equals 6. You know, that's what area is, right? We can go beyond that. These don't have to be integer, well, natural numbers. They can be fractions, or even irrational numbers. We can just multiply. We get the area. And this is all like, you know, you don't need me, right? You can like look at this and you can figure this out. Now, with a triangle, it helps to just kind of look at it a little and think about what we've got here. Thinking about it, do I have another color? No. Okay. Yes, I have another color. So let me not use this triangle first. Let me do something simpler even. Got a right triangle. So its height is the same as one of its sides. Its base is one of its sides. Look at that. Wait a minute. I can be a little creative here. I'm going to make it into a rectangle. So this is now H and this is B. And I know the area of the rectangle. Right? It's just, you know, H times B. But that's the rectangle. That's not a triangle, right? How do I know how much of this H times B is the triangle? Well, if you look, you can take this triangle, you can kind of turn it around and place it right over here. It's the same triangle. So there are 2 of these. Well, if there are 2 of these in the rectangle, the triangle has to be half of that. So here's a case where, okay, all right, the area of a triangle is 1/2 base times height. But you can kind of see that. You don't necessarily, you can see that picture. You don't have to remember that necessarily, or at least it fits better in the whole picture of things. Now, this is a simple example, but this is true in math a lot. A lot of the things we're going to learn here, you don't have to rely on some formula, some process I give you. A lot of it you can, you know, you may not remember all of it, but a lot of the pieces you can put together yourself. So I just want to encourage you to, you know, this is probably going to be one of your last hurdles in math. And I realize for some of you that's all you want to do is get over that hurdle. But you know, we're in college, and college is a good time to kind of expand your view of the universe. You know, maybe I grew up and I didn't know everything I need to know. And I'm not trying to ask you guys to go on and get your PhDs in math. I'm just saying, you know, something to think about. You know, because it could make life easier too, in many ways. certainly in this class. Okay. There's something else I wanted to look at here. I absolutely would be happy to do that. Take a look at your exam. If there's anything you want me to do, you'll let me know. I'm happy to go over them. Make some room here. So, number 9 gives you a fraction. And it says, I want an equivalent fraction. And I'm telling you I want the denominator to be 28. So it's this number I'm looking for. What number here makes this equal? So, what I think the simplest strategy here has 2 parts. Let's skip the first part that makes it easy. We can cross multiply. Just call this x. And I can say, without any question, that 49 times x, that's this multiplication, must equal 21 times 28. And therefore, I'm going to divide both sides by 49 to get my x. Now, I skipped what I think is a step you should at least look for. It may not always work, but you should look for. Is this in lowest terms? And that's where we get back to this factoring thing. 21 is 3 times 7. 49 is 7 times 7. Oh. So I can just take this fraction, 21 over 49, rewrite it 3 times 7, 7 times 7. And 7 over 7 is just another name for 1. So I can eliminate it. So now my problem's a lot easier. It's 3, well, the numbers are easier, equals x times 28. And now when I do my cross multiply, I get 7x equals 3 times 28. I divide by 7. And then I also want to notice that 28 is 4 times 7. This is 3 times 4 times 7 over 7. So once again, I can get rid of that 7, and then I'm left with 3 times 4. So I know my answer is 12. Now, that's just one strategy. In math, it doesn't matter. As long as you obey the rules, you go about things however you wish. A different way to go about this would be to say, well, what do I have to do here to get 49 to be 28? Well, 49 is 7 times 7. 28 is 4 times 7. So in this number, if I get rid of one of the 7s and put in a 4, that would be 4 over 7. I'm going to get 28. But of course, I can't just do that to the denominator. I have to do the same thing to the numerator. Multiply the denominator by 4 over 7, and I get 28. I multiply 21 times 4 over 7. Well, again, now it's useful to note 21 is 3 times 7. So that's going to eliminate this, and then it's going to be 3 times 4, and I'm going to get 12 again. You can go about things in different ways. You don't have, if I show you some way and you know some other way that works, it's fine. This is not follow the leader. This is kind of think it through. So, okay. Are there any specific problems someone wants me to go over? Yes. Okay, problem 12. I'm so glad. You know, I should have picked this one out myself. By the way, we're in the near future. We're going to review exponents again because they're important and they're going to come up in another section. So this isn't the last view, but let me go back to what I was saying before about you can figure it out. All right. I'm gonna try and do this problem in the most rudimentary way I can. And forget about my laws of exponents. I'm just going to use what I know. All right? I know that this exponent means take this stuff and multiply it by itself 3 times. I mean, use it 3 times. So I'm just going to write it out. 3x squared y, 3x squared y, 3x squared y. Okay. Got a bunch of factors there. And I've got 3x to the 5th y. Well, I know that if I have some factor in the numerator and in the denominator, I can drop it, because it's just 1. Right? 3 over 3 is 1. So I'll get rid of that. Now here I've got a y here. Why not do that? Get rid of the y. Okay. Now here I've got an x to the 5th. I want to rewrite that. And you'll see immediately why. That's x times x times x times x times x. It's 5 of those x's. I want, like, rewrite this times x times y. And now I can get rid of 2 of the x's. Okay? I think it'd be better to erase them. Okay. Again, I've got x squared, so that's 2 x's. The y. Oh, I got 2 here. Oops, not the y, the x's. And I've got 2 x's here. So I assume you all know, the trick with the numerator and the denominator. You can get rid of factors. And if you're not quite sure what to do with this, using laws of exponents, you can at least kind of, there's nothing wrong with writing this all out. Got 1x here, I'll get rid of that. And then I just have to figure out what do I have left. Well, I've got an x. I've got a y and a y, that's y squared. And I've got a 3 and a 3. And that's my answer. Now, it's the long way around. You know what you're doing, it's the hard way. You know what I'm going to show you in a second, it's the hard way. But it gets you there. And in math, it doesn't matter how you got there. All right? Okay, so now, if I were to instead use the laws of exponents, I would say Well, this 3, it gets distributed here. So I end up with 3 cubed. X squared to the 3, well, in that case, I multiply the exponent. So that's x to the 6th and y cubed. And I'm going to rewrite this just so it's clear. This is 3 to the 1, x to the 5, and y. And when I'm dividing by exponents, if I have the same base, I can just subtract. So this becomes 3 times 3 minus 1. There's my 3, there's my 1. X to the 6 minus 5. Y to the, again, there's a 1 there. 3 minus 1. And I get 3 squared, x to the 1, y squared, which is again 9x squared, an answer. That's if you know the laws of exponents, and you can use them. But you see here, you don't have to do that. You can just kind of write it all out. And I encourage you to go through this kind of dance by giving you all the time you need, because I'm not concerned about making you speed demons. Right? You should know the laws of exponents. That's part of the class, but you can still get there. Okay. Any other specific problems? I'm glad you brought that one up, because I should have mentioned that.
I have a question.
Mm-hmm.
On problem 11,
Okay.
and then problem 12. So I was like thinking about this on the test. Because it says 5 to the 3, 5 to the 6 gives you 9. But then you times it on this one and you added it on that one. So what's the rule?
Ah. Well.
What did I make a
Well,
mistake?
let's try and, yeah. You're unclear, let's try and make those clear. So the general rule is, I'm going to use b for base to the n times b to the m equals b to the n plus m. Let me give you an example. Okay. 7 squared times 7 to the 5th. So here, b is the 7. Well, I could write this as 7 times 7, right? That's what 7 squared means. I can write this as 7 times 7 times 7, 7, 5 of those. 2 of these. I add these together because I have 1, 2, 3, 4, 5, 6, 7. 7 to the 2 plus 5 is 7. So that's why on number 11, the answer, 5 cubed times 5 to the 6th is 5 to the 9th. Base is the same. I can just add the exponents. So that's number 11. Now that's different from this. Let's say I said 5 cubed squared. So first, I'm going to take 5 times 5 times 5. Right? That's what this is, 3 of them. But now I have 2 of these. So this is 5 times 5 times 5 times 5 times 5 times 5. So I've got 3 here, 3 here. I've got 2 times 3 is my 5 times 5 times 5 times 5 times 5 is 5 to the 2 times 3 is 6.
Okay, I get it.
Catch that?
I get it.
If you're not used to working with this stuff, it's foreign at first, but when you see how it makes sense, then it kind of fits together a little better. Okay, let me just see if there's anything else to comment about. Um, okay. Yes,
Can we go over the extra credit?
there's an ambulance.
Can we go over the extra credit?
You want me to go over the extra credit?
Yeah.
Okay. Let me just also say that this extra credit is kind of where we're headed in terms of the kinds of problems we're going to need to be able to do. We weren't quite there. There was a problem like this in class, but I didn't expect anyone to do this. There's no, when you see extra credit, it means it doesn't count negatively to your grade. You skip it. Right, so you have $100, and part of it you're going to invest at 5%, and part of it you're going to invest in 8%. And at the end of the year, you want to end up, well, you did end up with $106.65, $106.65. So I'm trying to figure out, how much did I put at 5%, or did I put at 8%? And let's just do some real quick kind of look over here. If I put $100 at 5% for the whole year, I put it all in this bucket, well, I'd make 5% of the $100 is $5. So I'd make like I got $105. If I put it all in this bucket, it would be $108. We're not going to do this guess and check. You can already see how between putting it all here and all here, well, the real answer has to be somewhere in the middle. Right? You can't make more than 108. You can't make less than 105. Well, okay. So the way I do this is, we call this algebraically. I use some variable. I'm going to say, all right, the amount I'm going to put at 5% at some number of dollars is X. Well, if the amount I put at 5% is X, what's left? What didn't I put at 5%? It's an expression for that. In other words, if I give you $100 and you give me 60 back, you have $40, right? 100 minus 60, right? So it's 100 minus X. So this is what I'm calling the amounts that I'm putting at 5% and 8%. You could do it the other way. You could make this the X and this the 100 minus X. Doesn't matter. You just have to be clear. All right. If I invest X dollars at 5% for a year, well, if I invest $100 at 5%, I get 100 times 1.05. 5% is 0.05. 1 is what I start with. 100 times this is 105. So when I'm doing this with X, I multiply X, I'll use the dot for multiplication, times 105. And that's how much I'm going to make here. X times 1.05. I don't know what X is, but we'll get to that, right? Oh, I got it in the wrong column. Sorry. X times 1.05. That's how much I'm going to make off my 5% investment. My 8% investment well, we invested 100 minus x, so we multiply that by 1.08. And that should equal 106.65. So now we have an equation, the solution which is the answer to this question, how much we invested, 5%. All right, so now we have to do a little work. So I'm going to write this 1.05x. I'm going to use the distributive property here. 100 times 1.08 is 108 minus 1.08x equals 106.65. Well, I have two quantities with an x in them. Let me rewrite this. 05x minus 8x plus 108 equals 106.65. Now, if you don't like subtracting bigger numbers from smaller numbers, it gives you negative numbers. Like here I want to subtract 108 from both sides, right? So I'm going to get 106.65 minus 108. And now I'm going to factor this, x times 1.05 minus 1.08. Well, if you don't like dealing with negative numbers, we can just multiply both sides by minus 1. That will reverse these and reverse these. So x times 1.08 minus 1.05 equals 108 minus 106.65. All right, x times 1.08 minus 1.05 is 0.03. 108 minus 106.65. Well, if you need a calculator, okay, you're forgiven. 1.35. Why do I feel like I've gotten the wrong answer already? That's it. You know where I made a mistake? I feel like I must have made a mistake because I'm sitting so close to the board. And maybe not, I don't know. We can check when we're done. So, of course, I'm going to divide both sides by 0.03. And, to make life easier, I'll move the decimal point over on the top and the bottom. That's multiplying the top times 100 and the bottom times 100. So now I have to just divide 135 by 3 for 12. It's okay. 45. Okay, what is this? What is x? X is the amount I invested at 5%. Should be $45. What's left? 100 minus that is $55. And now I can check my work. I can multiply this by 1.05, this 108, and see if I get the right number. Did I get that right? Yeah. Yeah. Okay. Thank you. Yeah. All right. This was a more complicated, difficult problem. But we're going to practice some of these at some point. This happened to have to do with percents and investment and stuff. But solving equations with an x is going to become hopefully second nature before we're done. Any questions about this? I do want to say, I wrote a lot. I probably wrote more than I needed to. But you shouldn't feel constrained. I mean, I give you, I give you the backs of all these sheets. And if anybody ever needs extra scrap paper, you can always ask for it. This is not, we're not in the ecology business here, saving trees. We're trying to learn math, so. Okay, oosh. This period is just rushing away. Right. Fortunately, we have a somewhat short topic to cover. So, the other day we were looking at a certain kind of equation and its graph. Is that right? I think so. Well, I guess I should get back up here. Okay. So we're not like, it's not a mystery here. We're going to look at something called the point, the slope form of the equation of the line, which in your book is section 4-5. Okay. So last week we looked at an equation of a line that looked like this: y equals mx plus b, where m is something we call the slope, or delta y over delta x, and b is our y-intercept. So as an example, if we had y equals 2x plus 1, we can graph that. This is our y-axis, our x-axis. Because we can see our b, our y-intercept is 1, we know that the line goes through this point. Since its slope is 2, it's our m, we know the change in y over the change in x is 2. So if we go over 1, we have to go up 2. And really, we only need 2 points to graph the line. So that would be our graph. Now, I think we've come across this problem in the homework that goes like this. We have a line, to say this line with slope, let's say 3, and it goes through the point, I'll make something up, 4, 1. And I say I want the equation of that line. Okay, so I look back at my general form and I go, all right, I know it has to have this form, y equals mx. Well, I told you what m is, it's the slope. And I don't know what b is. But I do know this point is on the line. That means if I plug this x and this y into this equation, the equation has to be true. So y equals 1, x is 4, plus b Well, now I have a simple equation that I can solve for b. Right? 1 equals 12 plus b. I subtract 12 from both sides. 1 minus 12 is just the negative. 12 minus 1 is minus 11. And now I can write my equation, y equals 3x minus 11. So hopefully you would know how to do a homework assignment that asks this kind of question. And another one, and another one, and another one. It would get kind of boring. You keep doing this whole thing. So in math, what we do is we try and generalize. And we do that by writing these things out algebraically. So now this is like a little bit of magic, nothing up my sleeves. Let's do that same problem, but in a kind of mysterious, magical way. So I have a line, and its slope is m. Okay, and here it's 3, here it's m, and it goes through a point. And I want to be careful because these x's and y's are not variables. There's just some point x1 and y1, and we're going to use those just like we used 4 and 1. Okay. Well, I already know the slope is m. Okay, good. Equation is fine. I know if I plug these in, it has to work. So I say y1 equals m times x1 plus b. And here's the weird part. Even though I kind of don't know what these are, they're not variables. They're fixed, whatever they are. So let's go ahead. Y1 minus mx1 equals b. So going back to my original equation, the solution is now y equals m times x plus b, which I can see here is y1 minus mx1. Okay, now let's be careful. This is the same y and x as before. We know m, we know y1, we know m, we know x1. Like if we're given a problem like this one, we can say, well, y equals 3x plus, what was y1? 1 minus 3 times 4. And we get the same solution as we got over there, yx. This is minus 11. Okay, so we're halfway to where we want to be. Okay, remember we're trying to find the point-slope form of the equation. That is, we want the form of the equation just in terms of points. This I could call this the slope point form of the equation. If I have a point and a slope, I can just use this. But we want to go a step further. And that's very easy. Instead of saying I have an equation where I know the slope, let's say I have 2 points, x1, y1, x2, y2. Well, I'm already halfway there, right? I already know it's y equals mx plus y1 minus mx1. But in this case, I don't know what m is. I have another point. How can I use that? Anyone remember how I can use 2 points to find m, the slope?
y2 minus y1, x2 minus x1, over.
Okay. That's great. Everybody catch that? This is my delta y over delta x, which is my slope. I just took the coordinates of the 2 points and I subtract from y2, y1 and x2 from y. You can do it the opposite way too, right? You can say x1 minus, well, y1 minus y2, x1 minus x2. All right, let's see. I hope this doesn't look too complicated. We're going to plug it in, right? y2 minus y1, or x2 minus x1 times x plus y1 minus, well again m, y2 is y1 over x2 minus x1 times x1. Okay. Now that's kind of ugly looking. So what we want to do is see if we can make it look a little prettier. Let's multiply both sides by x2 minus x1. That's what's in the denominator. Guess I'm going to use my space here. So I've got y times x2 minus x1 equals y2 minus y1 times x. Okay, so I multiplied this over here. That gets rid of it here, so I just have this piece here. I have y1 times x2 minus x1. And now I have minus y2 minus y1 times x1. Well, this still looks pretty ugly, doesn't it? Maybe there's something we can do here. Make it easier. y1 x2 minus y1 x1 minus x1 y2. Well, minus a minus is a plus, plus x1 y1. I'm subtracting and adding this. So that goes away. So let's see what we have left. Y times x2 minus x1 equals, I'm just going to write it this way, x times y2 minus y1. And then I just have to add y1 x2 minus x1 y2. That is point slope. I don't know if that was where I was going now. And you know what? That works to your advantage. It means I have to go figure out what I was doing and come back on Tuesday. No homework. All right. I think that's actually what I wanted. All right, and hope to see you all Tuesday, or if not before in my office hours on Tuesday. Anyone has anything they want to talk about? stop you at your door for about 30 seconds. I did want to say something earlier I forgot to say. You know, sometimes when I'm up at the board, what I want to show you is the result. The result is important. Sometimes it's the process. Here's the result, it's not the process. So if the process was confusing, don't worry about it. I'll try and be specific about that, okay? All right, thank you. One more? One more?